Alright, so this is going to be a pretty quick video where I just go over some of the characteristics of time series data. So the first thing I like to talk about is the when and where. So it's pretty obvious, but time series data pretty much always involves a time element. So when you think about data, some data automatically comes to your mind where there's a time involved. Things like health metrics or server metrics. Infrastructure monitoring is normally what we tend to call it, but I always tend to mention things like your health monitor tracker, like for example, I wear a Fitbit. That is going to be time series data. Roughly every second or so, it is recording metrics off of my body, my heart rate, my temperature, etc. That is all based off of time though. For that, it's going to be probably seconds or maybe even on the minute. In certain cases, it might be down to the nanosecond. So time series data always has the time element. And then from the where, it can be many different types of sources, but we do tend to see, like I said before, infrastructure. So from there, we break it into three different types. You have your metrics, which is something I just described, which is regularly collected. So that means every single metric is coming in as you expect it, on the dot every second, on the dot every minute. It is consistent. Events are irregular. So this can be something like a button is pressed, or you're only logging data when something goes wrong, when there's an error, for example, within your logs. That would be irregular. Hopefully your error is not consistently happening every 2 seconds or every 2 minutes. It should be irregularly happening, same with a button press or something like that. Traces are a complete event or request. So a trace is normally defined as, tracing when it comes to collecting, monitoring data for things like server infrastructure, or just in general, when you click on something on a website, it tends to call for a lot of things. It tends to call for lots of outside data, vendors, etc. And when it makes those calls, it will give you a trace stack. And in that trace stack, you can see things like what took the longest to run, or what was maybe failing, for example. You can see within the trace stack the exact trace that was the issue. So here are some of the use cases that some of these I've already kind of mentioned: the track and monitoring application infrastructure, robotics and green energy, especially we see this in warehouse. So time series databases in particular address a few major issues. So you're normally dealing with what we call a high ingest. So this is a high amount of data streaming in at what's normally a nano or at the very least second precision. Now, obviously, you can use streaming technology. There's many options out there. But for some people, they just want a database that can just automatically work with that ingest. They don't want to have to put something in front of it to basically, make the flow a little lighter, basically, into the DB. So it's a little bit more controlled. Compression. Obviously, when you're dealing with a scale of data where something is being sent to you every single second, it's going to get pretty big pretty fast. So the ability to have very good compression, especially after you're done with that real-time monitoring, is really important for, not breaking the bank, basically. Cardinality is the ability to store wide rows. That basically just means that your timestamp data has lots of metadata on it. It's lots of little details like the location of your warehouse or device ID name, stuff like that, things that help you understand your time series data. And then, of course, querying on time is the big one. So instead of indexes or values, we are specifically indexed on the time value. So that means that when you query with things like in the past 5 minutes, on machine X, what was happening, or rather it would be just, in the past 5 minutes, what was the temperature gauge on machine X, that's going to be a lot faster with the time series database that's already geared towards time series data and indexed on time. And just to kind of wrap this up here really quick, this is just an example of other databases within the time series space. So you have things like a relational, which isn't really a time series database, but it can store time series data. We normally find, though, it tends to not scale very well. That high ingest load and the ability to query on a timestamp instead of an index tends to be the fault of these databases. Then you have the NoSQL DBs, which do tend to do a bit better on those two capabilities. So MongoDB, for example, does have a time series section. They can definitely store time series data. They're still not indexing on the timestamp, though, so you still might have query time problems, like if you need your queries back out fast, and you still might have issues with ingestion. Elasticsearch is commonly used for logging things from, search metrics and such. So in that way, they are already kind of being a time series database, but that doesn't mean they're perfect for more broad use cases, things like industrial use cases, basically things that are not searching related. And then you have something like influx data, which is obviously very specific for time series data. That's all that we work on. We don't store your files like Mongo would. We don't necessarily store your search history like Elastic, and we certainly don't store as much types of data as a SQL database will store. We are specific for time series data. And hopefully that kind of helps you understand what time series data is, when it's appropriate to use a time series database, and what are some of the benefits.